Yeah, so welcome. That's it. We want to jump straight into our final stretch of course 3711 revision classes, and we're going to look at a whole bunch of topics. And the strategy that we employ every single time is that we look at one topic at a time according to a timetable on the portal. So if you go through the portal, I've listed all the topics that we're going to be looking at in the order that we're going to be looking at those topics. And after that, we'll just start looking at general exam, past exam papers, and discuss as much as we can. And also, please take note that our revision classes are more for answering questions, not teaching, or tutoring, because all the content that you need in terms of concept is covered in the self-study videos. So the approach that I always employ is that you must look at the self-study videos first, and then we do the lesson. So today we're looking at OOP. So my understanding is that you guys have already looked at the OOP stuff. I've seen some discussions that were going on in Telegram. So well done to those who've been studying. I've gone through all your Telegram chats. I've looked at all the questions that we asked. And I'll try and answer as much of those questions as we go through each of the topics that we covered. I think there was a lot of regular expressions. There was a lot of OOP, which is what we are doing today. So that's what we're going to be looking at today, OOP. So as usual, or moving forward, please just make sure that you look at the video addressing the next topic, and you try and practice and try and look at some questions, because those questions are what I need in the class. So tomorrow we are moving on to reflection, which means I do expect you guys to have gone through the reflection videos by tomorrow, and you should have attempted a few questions on reflection. There are a lot of past exam papers that you guys can use at your disposal to practice. And if there are any questions, or if there's anything that you encounter that you don't understand, you must bring those questions to the class. Then the other issue is, so today we'll be looking at strictly OOP questions or UML diagrams questions and anything related to that. Just give me 1 second, please. All right. So I was saying that, so the way we do this is, so tomorrow we're going to be looking at reflection, right? You are free to bring any questions to do with topics we would have covered into any lesson. So tomorrow you can bring questions on reflection or UML diagrams. After reflection, we're going to go on to MV programming, which means in all those lessons, you can bring questions on reflection, questions on OOP or UML diagrams, and that's how we move. So all our lessons or all our classes are going to be discussions, because the point of us being here together is so that I can clarify any gray areas that you have, or if there's anything that you're going through that you don't understand. The reason why we are all here so that you can ask those questions, and then we can address them together. We can do those solutions together. So in terms of learning and understanding those concepts, please use self-study videos. Then for lessons, I want questions. I want you guys to ask as many questions as you can, as dumb questions as you can possibly come up with, because it's those ones that bring out any gray areas or anything that is not making sense. Because if I start teaching you right now how to draw UML class diagrams and all of that, I'm just repeating what's already covered in the self-study videos, and you used to go out there and you try things and you still have questions and no one to help you. So those questions are why we are here today together at the same time. So these are open discussions. So please feel free to jump in and ask questions. If you already have questions to do with UML diagrams, you can bring those ones. And that's how we're going to move from today for every single day until you guys write. Okay. There's a question already. You can go for it, Yusuf.
Yes, Edmund. I just want to know, for the composition aggregation relationships,
Yes.
do we know when to use that in a particular when designing UML diagrams?
Good question.
Especially with regards to pointers.
Yeah, so remind me if I don't address that before the end of this lesson, but I think we've got one of the questions that you have already asked that has something to do with aggregation and composition. So I'm going to address that question when we get to that question.
Okay.
Anyone else with a question right now that you want us to look at? Okay, so cool. That's some housekeeping stuff just to make you guys understand how we're going to proceed from today for the next 17 lessons. That's like 17 hours at your disposal of me, you asking questions. So there is no excuse. You have to ask as many questions as possible. That's the whole point of these lessons. The self-study videos won't cover everything. I do know that there are some certain concepts that are not covered there, but that's the point of then having to meet and discuss all those topics together, because I do know sometimes that there are certain areas that I didn't cover in the self-study videos under the revision series. But yeah. All right. So today we have gone through some of the questions you guys have been discussing on the on Telegram. This was one of the questions that I've seen. I've seen some diagrams. We'll look at those solutions and we'll discuss. But generally speaking, right. And jump in if you've got any questions. You want to know how to all right, okay, so it's something distracting me here. You want to know how to draw UML class diagrams. And I've always said that drawing a diagram, especially your diagrams, are easy because they're all very consistent. They all require the same concepts. It's usually different scenarios, but your diagrams are always the same. Whenever you draw a UML class diagram, I'm going to expect to see some inheritance. I'm going to expect to see some container or containers. When I say container, I mean a list of something or lists of something. And generally, you apply a design pattern, which can be factory. And that's usually what happens with your UML diagrams. If it gets complicated, you may have some serializer design pattern. So generally speaking, whenever you're drawing a diagram, things to look out for that are very common in almost all your diagrams. You've got inheritance somewhere. So inheritance, that's a given. I've never seen a UML class diagram where you don't do inheritance. So you've got inheritance, you've got containers. So you're going to have a list of something somewhere. And then you're going to have design patterns. In most cases, your design pattern is going to be factory method. That's like the most common one that you see, factory method, and sometimes strategy. We'll talk about this right now. Strategy, because it's mostly the same thing, the way Eunice explains it. You're going to have some serialization going on, serialization. This is when you talk about writing or reading from a file. So when you've got like a writer or a reader, these are all classes that you create. So these are like the basic things that you have to watch out for whenever you are looking at designing any UML class diagrams. All your questions I've seen so far encompass these things. But I'm not saying you're going to have to start saying, where do I apply inheritance? It's always good to understand the context, understand what's going on, and then you can draw your diagram according to the question. But I'm simply saying, usually it turns out to be, all these things that you end up applying. Okay, so for instance, in this case, you want to figure out your entities, and that's the inheritance bit of things. Your entities, what are the objects in your question or in your scenario that need to become classes and then leading to inheritance. So the first thing you normally do is identify entities. And one of the easiest ways to identify entities is to look at anything that is an attribute, anything that is a name, that is an attribute. Like in this case, they talk about volume and they talk about diameter, all those things like a code. Those things hint you on this item becoming a class, right? So let's quickly go through this question. I'm cruising and I'm going to be fast because I'm hoping you guys have looked at these questions. So, and you've already gone through the videos that explain how to draw diagrams in detail. So I'll try and summarize as much as I can so that I can cover as many questions as possible and give you guys enough time to jump in and ask questions. So in this case, we've got transport cargo around the world is essential in ensuring that customers have access to the goods they need and want. All such items are packaged in some sort of container, which for the purposes of this scenario has a volume. So a container has a volume. Immediately, I know that a container is going to be a class. Somewhere in that class is going to have a volume. Generally, there are two kinds of containers. A box where we want to know whether it's a cube shaped or not. And a cylinder where we want to know its diameter. For transport, containers are packed onto pallets and pallets are then included in a load where each load will have a code. Simple. Considering the scenario given above, draw a partial UML class diagram that captures the scenario. You should include the necessary classes, class attributes, and class relationships that are mentioned in the scenario. You do not have to include the client, class nor include constructors, access specifiers, or other methods in the classes you specify. So you don't need to do get this, set this. They only want attributes only, no constructors, no get set functions, and or any other methods that may show your intent with your design. So coming back to this question, one of the things I pick up quickly is that we have a container, right? So, and this is all about containers, and that usually hints me in terms of inheritance. I'm gonna have containers here, and in terms of inheritance, the moment you start getting types of something, that usually give you your subclasses, because whenever you do inheritance, you've got like a type of something, or rather, let me say this: you've got an object, right? You've got an object, and then inheriting from this, you've got type of object 1, you've got type of object 2. These normally become your subclasses. So that's the general idea behind how you do your inheritance. So looking at this question, I'm thinking, okay, so we've got a container that definitely becomes a class because this container has a volume. So the moment something has an attribute, it's a given, it's a class, because where do you store the volume? So my container is a class, which is a volume, but generally there are two kinds of containers. Now there's a box and there's a cube. These become subclasses because these are types of containers. And to further confirm that, your box has a diameter. I mean, your cylinder, you've got a box, you've got a cylinder. Those are the two types of containers that you have. Sorry. So yeah, so that then means your box and your cylinder are going to become your subclasses. And to further confirm that a box and a cylinder are also classes is the fact that a cylinder has a diameter, is an attribute. A box has a Boolean that says, is it cube shaped or not? So this could be like a Boolean item that simply says true or false. Is it a cube or not? So these attributes are telling me that I have a container that is two subclasses, a box and a cylinder. So the first thing you want to do is just figure out what classes are included here. Before you start stressing about attributes and what attributes to put there, what you really want to do initially is just a general idea of what classes do I have and how are they related? Where is inheritance? Who is linked to what? So in terms of the inheritance bit here, so you've got your containers, and then for transport purposes, containers are pegged onto pellets, right? So you've got these pellets, and then that's why you start asking questions. So does a pellet become a class or a container? Because in general, any list of items becomes a class. So you've got a list of books that becomes a class. If you've got a list of containers, that becomes a class. So in this case, you're being told containers are pegged onto pellets. So with reservation, we may have like a pellets class, which is a combination or a container. Let me not use the word container to not confuse everyone. We just want to say list, right? Because container usually means a Q list, a Q vector, a Q map, all those container classes that we have in Qt. So in this case, I'm going to use the word list so that you can differentiate when I'm saying container, because I'm referring to this container, and container because I'm referring to a list or a Q map or a Q vector, whatever container you choose to use. So in this case, you can then say, well, do I make pellets a class, which is now a list of my containers? So you can reserve that idea. It's a good one, but let's wait. And pellets are then included in a load where each load will have a code. So now we know that a load is definitely a class because it does have a code. So anything that has an attribute becomes a class. So in terms of my load here, do I put containers directly under a load? So because you've got pellets that are then pegged onto a load, what I would then do in this case is make a class that represents a pellet. So a pellet becomes a collection of containers, and then a load becomes a collection of pellets. So in this case, I've got two lists, which both become classes. All right. So let's stop there. That's the general idea. And then you apply your design patterns. We'll come back to design patterns. So looking at the general solutions that you guys had, I realized that you had a good idea in terms of just generally understanding that a container is going to be a class and a box and a cylinder are going to be my subclasses. Perfect. And then one good thing is that your pellet then becomes a collection of your container. But here's a problem. If you just say pellet, you're just creating a class. There's nothing here that's telling us that a pellet is a list of containers. And there are three ways in general to have a list. Of those three options, let's talk about two. If you want a class to be a list of other items, you can either inherit from a queue list or you can include the queue list within your class. So what I was missing here is, how is pellet a list of container, right? So if you choose to put containers within a pellet, that means your pellet becomes a list of containers. Now, in this instance, you've got two options. And one of the easiest options around doing making a class a list is to simply inherit from any container that you want. It can be a queue list, queue vector, whatever you want to choose. Then you make a container there. So you inherit from a queue list of type container. Now this is a list, and therefore this now applies, right? I see there's an arrow here which is wrong. That should not be there. So you gotta watch out for for things like these little errors here, because that may cost you. Now I'm happy with this. I've got problems with because a pellet does not have a code or any attributes. It's simply a list of containers. So I would not put any attributes inside pellets, right? And then you are further combining pellets into your load. Now this here means association. And then your diagram becomes wrong because you are saying a pellet uses a load somewhere. Whereas in actual fact, what you're trying to do is a load is a collection of pellets. So this here would not apply. You would want to apply the same concept that you applied between container and pellet, same concept between pellet and a load. That's what you would want to do, just in terms of generally understanding your classes. Now, the second tip I've got for you in terms of drawing your diagrams, do not use anything that's going to waste your time. You've got 2 hours to answer all questions. You don't get extra mark for using a cool tool. No, all right? If it means you're going to draw on paper, take a picture, then take that thing, put on a document, do that. If you're writing your whole exam on paper, I don't know what options you guys have. Do whatever you're fastest at, all right? Because you can spend 30 minutes fiddling with this tool, whichever you were using, and trying to get the right arrows and this and that, and you are wasting time trying to draw a diagram with a tool that's going to cost you just time trying to get a diagram out. So you're going to have to practice which tool you're going to use to draw a diagram. If you're going to use a tool, that's fine, but just make sure that you're quick and you are fast. From other semesters, I've seen other students creating templates, and then during the exam, they just fill in the details. So because you'd expect inheritance somewhere and a container somewhere. So I've seen students with like templates of these diagrams that they would then use during the exam. And it's a gamble, but from what I've seen, in most cases, they were very useful because these diagrams are usually in the same format with a few tweaks. So other students created templates that they would then use to then apply the actual scenario onto that template. You can delete a few things or copy and paste a few things if you've got like 2 or 3 templates of these diagrams. So you're gonna have to choose which way you are very quick at and do that. Don't waste your time with something that's gonna take you time. So find time to practice drawing these diagrams and figure out which way you're most comfortable drawing the diagrams. Another solution that I looked at was this one, which again does well in terms of having your container, your box, your cylinder. Your containers are pegged onto a pellet. And in this case, you chose to put the list within the pellet, which is fine. So you can either choose to use inheritance or you can put the container within your class. That's also okay. So you see what I've done here is I've inherited from a queue list. One way is to just take this queue list and put it within your class. Perfectly okay. So like what was done here. Then the only correction here is that we don't want this on this side. It has to go on this side because your aggregation or composition, diamond goes onto the parent. The object that is composed of that's where you put it. So the parent carries this, and then that's just an arrow going that side. So that was reversed. Then this was fine. This was not required because they didn't need any functions to show how you're going to put containers. It was not necessary, but regardless, okay. Then you take your pellets and you put these in a load, which is okay. So in this instance, you've got now a queue list of pellets and your code and your aggregation, and you're done. So in terms of generally understanding your diagram, that's what you were having. You had, if I redraw this, you had a container which is made up of a box or a cylinder. So you've got container made up of a box or a cylinder. Your container is further pegged onto a pellet. A pellet is further pegged onto a load. That's generally what you were doing. And whether you use inheritance or you composition in terms of your list, that's fine. If you use inheritance, then this would then inherit from a queue list or whatever container you want of type pellet. And this would inherit from a container of type container, like that. So that's generally what you would want to do. Now, in terms of design patterns, whenever you see inheritance, right, you want to apply the factory method design pattern. I know we are going to discuss factory method a bit later, but because we're doing OOP, I'm going to preempt and discuss factory. So I'm just going to apply the factory classes here. So with factory method, all you can do is you can put your container factory here, container factory, and then you put your uses, and then you can do your creates there. So that's the next thing you would want to do when applying your UML class diagrams. Apply your factory method design pattern. And usually that's it. The rest of this diagram is just filling in the bits, which is putting in the attributes that are required here, the attributes that you would. So there's volume here, there's is cubed, which is a Boolean here. You've got diameter here. You've got a code here. I think you did that. So you've got volume, you've got is cubed, you've got diameter. Yeah, there. That's your attribute. And then you've got your load, your code, I mean, there, and that's it. So the only missing bit here was just applying your factory method design pattern. So yeah, generally that's how you draw your diagrams. Now, in terms of aggregation or composition, which is now this part and this part, when do you use composition and when do you use aggregation? Now, there are no hard and fast rules around which one you use. It just depends on your understanding, or it depends on the scenario and the lifetime of your objects. And when I say lifetime, the question you're asking yourself is, within your application, if I delete a pellet, should all the containers then be deleted also or not? If I delete a load, should all pellets be deleted, which in turn deletes all the containers? Now, there is no right or wrong answer when it comes to that. It just depends on your explanation or your understanding of what is right or wrong in terms of the lifetime of your objects. So in other words, you're asking yourself, can containers exist outside of a pellet? If a pellet is deleted, do we then have to go and delete all containers? Or if a load is deleted, do we have to go and delete all pellets and then delete all containers? Now, this question was actually asked for this paper under 1.2. Would you use aggregation or composition relationships in the design of this UML class diagram? Explain why you have or have not done so. So it now depends on your justification. That's the most tricky part. What is your justification, or what is your idea around the lifetime of your containers? Now, I can say I'm going to use aggregation, but before we talk about aggregation and composition, we've got to understand what it is. What is aggregation? What is composition? Now, in simpler terms, aggregation simply means that you can delete the parent in your application, but the actual objects would still be there, being used somewhere else within the application. That's aggregation. So the lifetime of your parent does not affect the lifetime of your children. So in other words, what I'm saying is, if we look at this diagram, we are saying that your pellet is a parent to your containers. So if I delete a pellet, does that mean all containers have to be recursively deleted? Or no, we can just delete a pellet and we still have our containers. We can still use them somewhere else. The same applies to a load. Now, the question becomes, do we need to delete containers if a pellet is deleted? If yes, then you use composition. If no, then you use aggregation, okay? If using composition, then you've got to switch to pointers here and here. If you use aggregation, I don't have to switch to pointers, but if it's composition, you have to use pointers. Now, one can justify and say, well, let's read this one. Aggregation objects have their own lifetime, but there's ownership, and child objects cannot belong to another parent. Now, you do not explain, you explain sort of like what aggregation is without explaining why you chose aggregation in this instance. So what you'd want to justify is, for instance, if I use aggregation here, I can simply say containers can be loaded and unloaded into a pellet, right? So if we destroy a pellet, we can load and unload objects from a pellet or from a load, which means the fact that we are destroying a pellet or unloading objects doesn't mean that we've got to delete them. So the lifetime of your container should be independent of to the lifetime of a pellet, because a pellet only exists during packaging, but containers can be put into a pellet and can be taken out of a pellet. So if we are taking containers out of a pellet, doesn't mean that if we take containers out of a pellet, we no longer have a pellet, but we still have containers. So we can create pellets, or we can move containers from one pellet to another. Some pellets can be dismantled to create new pellets, which means the lifetime of a pellet or a load cannot affect the lifetime of a container, because we start off with containers, which we then load, package into pellets, and then we package those pellets into loads. Those loads can be destroyed when you unload. For example, once you arrive at your destination, what do? You unload everything. There is no more load. The load is gone because we've removed all containers from the load. But the container should still be there. So that's how you can possibly justify using aggregation, not composition, because you are saying, no, the lifetime of a container cannot be dependent on a load, because pellets or because containers can be packaged or can be grouped and ungrouped into loads and pellets. That's like how you can justify your choice of aggregation in this particular instance. If you use composition, you would have to explain why you think the dependency, why you think the lifetime of a container has to depend on the lifetime of a load. But from this scenario, I would think aggregation is the right approach, because clearly containers exist before loads and pellets, and they don't have to depend on the lifetime of loads and pellets, because they can be loaded and unloaded into or from pellets and loads. So that would be my sort of like explanation around why I would choose to use aggregation. Okay, so that's this question that I saw on Telegram. There were discussions. You were generally in the right idea, but again, just choose a tool that you know you're quick at, so that you don't waste time during the exam trying to drag arrows and you're not quite sure which one to use, and you know how these tools work. If you're not used to them, those arrows won't behave. The lines would be snapping and doing all those crazy things, and you lose your mind. So choose a tool you're comfortable with. I think you're still allowed to just draw it on paper if you want. The challenge with drawing on paper is if you make a mistake, you might have to redraw the whole diagram. So with tools like this, you can just go and edit where you think you're wrong and move things around until it looks fine. So just practice until you figure out which way you are mostly comfortable with. All right. Have I explained this question? Do we have any questions on this question? Okay, Yusuf, I see your hand is up. I don't know if it's up from the previous time you were raising it, or it's up now.
Oh, it was up from the previous session. But I still Just wanted to ask another question.
Yeah.
How do we know when to use pointers or not
Yes, yeah. So
in the class?
if it's aggregation, you can use pointers or not, doesn't matter. If it's composition, you have to use pointers. And to be honest with you, with these questions, you're better off with pointers. Pointers are simpler, trust me on that. So if you're not sure, just use pointers. If you're not sure whether it should be a pointer or not, make it a pointer, because you won't go wrong with pointers. Because pointers will allow you more flexibility compared to non-pointers. Non-pointers will restrict you much more than pointers will in terms of flexibility and all of that. So if you're not quite sure when to use what, go for pointers. All right. So another question that I got was from a previous paper, 2021. And this one says, yeah, what's the time? Okay. All businesses need to manage their communication, and the simplified scenario used in this examination is based on communication strategies. The idea is that a user can select the type of communication channel and have a message sent out on that channel at some specific point in time. The application itself allows the user to set up the required options, and just the strategy and message will be displayed for the purposes of a brief history of messages sent. Okay, so you choose your strategy, code, date, time, you click create, the message is created, and it will be sent at some specific point in time. Okay, that's the thing. That's what's happening here. Apply the strategy design pattern to the scenario above that would also adhere to the following requirements. There are currently 3 basic strategies or channels for communication: Signal, SMS, and WhatsApp. Your design should include a strategy for each channel. Okay. All that is needed to create one of these is a type name. So we need to know, is it WhatsApp? Is it SMS? So you need the name you need the type to know which one to create. Once an appropriate type has been created, a setup function would be used to populate object instance data members, and the communicate function used to process the required information. At this point in time, it looks confusing, but they say, oh, a communication strategy UML class diagram has already been drawn up here. Note that you may abbreviate this class name to comstrat in your answers. Here's a class. Considering the scenario given and design decisions listed above, draw a UML class diagram for the strategy design pattern. You should include the necessary classes, class attributes, class constructors and operators, and class relationships to make it clear you understand how data will be managed and passed between classes. Label all your relationships indicated. However, you do not have to include the client or GUI class, nor indicate access specifiers. You may use a software tool, Okay, there we go, 11 marks. It sounds complicated. So the strategy design pattern, if you look around and you do your research, is quite different from the factory method design pattern. It's they're not the same, but from the way UNISA taught it last year, they interchange strategy and factory method. They just use one in place of another. So in light of that, I think it's safer to play it that way, right? Because with strategy, you still have inheritance happening, even if nobody says strategy, even if we don't mention the word strategy. If you are thinking the way we've been thinking, inheritance is inevitable, right? So whenever you read a question like this, take your time to understand exactly what's going on, because the first time you read a question, it always feels like it's confusing. You've got to learn to simplify your question, extract the details, and see a simpler picture of whatever is going on within this question, right? So one way to do this is to reread the question until you fully understand what they're trying to do without overthinking what's happening. But at the end of the day, we've got a message that needs to be sent. And there are 3 communication strategies. And this question is not about messages, it's about communication strategies. So it's about, how we are going to communicate. Is it WhatsApp? Is it, when you look at these things. So if you've practiced OOP and UML class diagrams, you can see quite easily that, oh, I'm going to have some inheritance going on here because I've got a communication strategy, which can be a signal, an SMS, or a WhatsApp. So those would start to hint you around, oh, okay, so these are my subclasses. And to further simplify your life, they sort of provided you with the base class. Like, here's the communication strategy. So if you're already thinking in terms of inheritance, you can see that they're doing nothing but trying to help you get a distinction. How awesome is this guy? So we do know that, I mean, we are going to inherit at some point. If you've got a class and the types of classes and objects, inheritance is going to happen, right? So, and in this case, this COM_strat class is just your base class. And it summarizes everything they've just told you here, because your class should have, once an appropriate type has been created, so you can create a signal, SMS, or WhatsApp, whichever one you choose. But we need to create one of these. All that is needed to create one of these is a type name. And the fact that you've got to create these is also giving you hints and ideas around making instances of classes, right? You're going to make an instance of a signal, SMS, or a WhatsApp. So these are classes. Now, once an appropriate type has been created, so you're going to make an instance of one of these three. A setup function would be used to populate object instance data members, and the communicate function used to process the required information. Now, we from the previous example where we with containers and boxes, cylinders, the slight complexity with strategy is it's concerned about functionality, a different way of doing something. But it doesn't run away from the fact that you've got types of classes. So the only tricky thing maybe about strategy is that on top of your inheritance, there's a function that's going to do something. And that function is common to all your classes. That's where strategy becomes interesting. For example, you want to do a search algorithm. How many search algorithms? You have plenty of them, right? You can do sequential search, you can do binary search, you can do, or maybe let's do sorting algorithms. You've got merge sort, you've got selection sort, you've got insertion sort. These become different ways of doing something. So if you're making a class that represents a sort algorithm, that means you're going to have a base class and subclasses, which are then types of your sorting algorithms, right? Now, in strategy, you are going to have a function that's common, because for every class, there has to be a function that you then call to do the thing that it does. For example, in this question, we are going to communicate and set up. It doesn't matter which one we use, whether it's Signal, SMS, or WhatsApp, we are going to set up and communicate. So the inheritance will still happen the way you understand it. You've got a communication strategy, and you've got three types of strategies, right? The only thing you gotta then do with strategies to include those functions within your classes, and it was done already for you here. Here's your class, which is your base class, with your code, your send time, and the message. And then you've got your setup and your communicate. It doesn't take away the usual inheritance that you're going to do. COM_strat is your base class. You've got WhatsApp, you've got Signal, you've got SMS. So when you're drawing this diagram, before thinking too much about anything, it's going to look exactly the way you would expect it to look. You've got your COM_strat class here. Then you've got, your WhatsApp. You've got your SMS, and you've got your Signal. So you're going to do your inheritance. Only that, for all these three classes, you are going to replicate these two functions. So all of them are going to have a setup and a communicate function. But now, in terms of the setup function, now this is where it matters to understand the context, right? Because this is your user code, that's your date, that's your message. So you don't need to override this function here in your subclasses. This can be done at base class level, which means the only function you need in your subclass is the communicate function. Why? Because each class does this differently. So the thing with strategy is that there is something you want to do, but in different ways. So for example, if we say we want to sort, right? You're going to have, in this case, right? You're going to have a sort algorithm, right? And then under here, you're going to have insertion sort. You're going to have selection sort. You're going to have merge sort, for instance. But in all these cases, what are you going to do? You're going to call a sort function. Sort, which means this sort function here is going to be common across all your classes, all the way from the base. But at the base level, it's going to be pure virtual or abstract, because each class has a way of doing this common task. Now, when we come back to our example here, what is that function? It's the communicate function, because each of these is going to do or implement this function differently. WhatsApp is going to do it differently, SMS differently, Signal differently. So in all these three classes, you're going to include your communicate function, communicate function, communicate function. That's what strategy is all about. So it's still inheritance, but when you're doing strategy, you simply include that function which should do the thing that your strategy is trying to do, right? So in this case, it's the communicate function. Other than that, there is nothing else. There's no container. There is no whatever. The next thing you do is your factory. Now you do your factory method class. So you go there, then you apply your factory, I don't know what you're going to call it, your construct factory, and you do your uses, and you do your creates. There. And you're done with this question. Very simple question. So all you were doing in this case is inherit from constructs, which is this class you've been given, and then you put this function in all the three classes that you're inheriting. So it's going to be here, here, and here, and then you do your factory method. Now that's how they explained strategy as per UNISA. But as per research, strategy does include there would be an intermediate class somewhere which is called the context. But let's do it as per UNISA. They want you to apply factory, and that's your strategy. They are more concerned about this part, like just being able to inherit and overriding your function, which is going to employ a different way of doing something. That's how you would apply strategy. So do pointers work for both aggregation and composition? Please also do an example with pointers when done. Yes, pointers work for both composition and aggregation. Nothing changes in your diagrams. Absolutely nothing. So you see this diagram that was done here. So he went with no pointer here. He went with a pointer here. Doesn't make a difference. And it's all aggregation. You could have gone with non-pointer, non-pointer. You could have gone with pointer, pointer. Nothing else changes in this diagram. It's still exactly the same. And that's why I'm saying, if you're not sure, just put a pointer here, put a pointer here. But whenever it's aggregation, it's safe to not use pointers because then it makes your intent very clear. But you can still do this with pointers and still make it aggregation. Only that the responsibility of deleting those pointers has to lie somewhere within your application, but not here. So we must not say a destructor if you then say it's composition. Otherwise, you can use pointers or non-pointers and flag it as aggregation. That's perfectly fine. That's perfectly okay. All right, so that was so all questions to do with strategy simply require you to do inheritance, and then you override your function. There's going to be a function that has to do something differently. So there's going to be one function that's common across all your classes. You put that function everywhere, and then you apply your factory method, and you're done. That's how you do strategy. So it's a very straightforward. The question sounded a bit complicated with a whole bunch of like things happening here, like 1, 2, 3. This has to happen and all of that, but nothing. Everything they said here, they did here. So all you were doing is just inherit from this class, override communicate function, apply factory method. That's it. So, and that's why it's important to learn to simplify your questions. When you read your question, remember that you're doing OOP. Eventually, you're going to end up with a diagram. There's no code being written here. So all the information that is being explained here and this diagram and wishing you a happy festive season and create buttons and all of these widgets and 1, 2, 3, all of that, if you're not careful, may just confuse you. You may spend time cracking your head trying to figure out what's going on with this diagram. When you click create, what's going to happen and when, how. Just try and simplify. Just breathe, simplify. Okay? That's what you got to do. Simplify. Why? Because in these questions, there's usually some details that are given in good faith to try and help you get the context. But in doing that, I've seen a lot of students confused because of those details. Like they're too much now. They just want to be told, oh, because your questions would be simple if they went like, oh, here's a class. Please inherit, override, communicate, and apply factory method, 11 marks. Everybody would get a distinction. But eventually, that's all you're doing if you think about it. Do they say it that way? No. What do you have to do? Simplify, okay? And we're going to see this a lot in these questions from now until we finish. All questions, usually the ones with a lot of explanations, be careful. Some of the jargon is just there, but it won't change any single bit of what you need to apply and how you need to apply it. So you just have to learn to simplify. And one of the ways to simplify your questions is to start thinking from the solution and work your way backwards. What do I mean? You start by thinking, I have to do inheritance and I have to apply factory method. Where? And then you figure out where you do it in the question. And that's the reason why I've always said some of the questions will only make sense if you already know the solution. So if your mind is thinking, I need something like this, I gotta come up with something like this. How do I end up with something like this from all of this stuff that they've given me here? You can simplify pretty easily because it doesn't matter what else they said here. You're gonna end up with something like this or something like this. It's gonna come back to this. Eventually, it'll come back to this. So you can simplify by starting thinking of the solution because you've seen these UML diagrams. You would have practiced, I hope so, by the 20th or 21st, you would have practiced enough of these questions. You'd know exactly what these diagrams normally look like. So if you see a question that's confusing, start thinking of the solution and start working your way backwards. Like, where's the inheritance here? Where is the factory method? Where is the container here? Is there some serialization going on? That way you can see easily from the question what they want you to do without even understanding some of the bits of explanations in there. That helps a lot. That helps. Why is constructs and communicate in italics? Because it's abstract or pure virtual. So remember, if we were writing code for this class, we wouldn't implement communicate in construct. Why? Because how do you implement it? The implementation details of the communicate function can only be done if you know how to communicate. So in other words, the communicate function is the one that then sends the message. So if we were writing code inside this class, we would write code to send a WhatsApp message. We would be calling WhatsApp APIs and doing whatever we need to do with WhatsApp SDKs to send a message. That will be happening here within the communicate function. If we're using SMS, we'd need to know how to send an SMS. Maybe we're using a bulk SMS platform with the APIs that we're calling and doing that. That code would go in the communicate function of the SMS class. If we're using a signal, we would be using, signals, right? In Qt. How do you do signals in Qt? And, figuring out how to send a signal, and all of that here. So the code for communicate cannot be done at base class level because how do you write it? How would you communicate? The implementation details of this function only make sense when you're at this level because now you know how to write communicate in WhatsApp, how to write communicate in SMS, how to write communicate in Signal. So at construct level and in almost all strategy design parent questions, it's always abstract at base class level because the implementation details or the strategy details lie within each strategy or within each way of doing things. So it becomes, if you think about it, it's impossible to implement this function at base class level. Because how do you do it? Because WhatsApp is going to do it differently. SMS will do it differently. Signal will do it differently. So the implementation details of this function only makes sense at subclass level. So at base class level is pure virtual. So we indicate, communicate in virtual, in yes. So if you're drawing a diagram, if you're using a software tool, you would make this italics like this. If you're using pen and paper, freehand, you would underline it to show that. I think they normally tell you, there you go. You can use an underline to indicate italics in the UML class diagram. That is if you are just using it if you are handwriting it or hand drawing it, right? But if you're using a software tool, you can just do it like this. So only at base class level is it like this. At subclass level, which means in your WhatsApp, SMS, and Signal, it's normal font because it's a normal function, right? It's a normal function, normal font. If we were not given Fig 2, how would we figure out to make it abstract? Yes, good question. So with strategy design pattern, your function is always abstract at base class level because it should not make sense to implement that function, right? Because, for example, if I'm going at this, if you look around there, past examples with this example here, how would you implement the sort function at sort algorithm level? Because you've got insertion sort, selection sort, and match sort. These are different algorithms. So this function cannot be implemented at base class level because which algorithm are you going to use at base class level? Because at insertion sort level, you can use insertion sort here, selection sort here, match sort here. So at base class level, if it's strategy, you can always know that it's abstract and always in italics, right? But at base class, at subclass level, then this can be implemented. And again, remember, it depends on the scenario. Like you saw that when we were doing containers, we didn't talk about pure virtual and abstract because there's nothing to make abstract here. Get volume retains the volume. It's you actually implement this function at this level and it does this. So pure virtual functions are normally, it's usually easier to figure out if the function is pure virtual because at base class level, if you think about how you would implement it, it should not make sense to implement that function at base class level. The implementation details of that function should only make sense when you go to the subclass level. So that's normally, so for strategy, I think we can say it's pretty obvious that at base class level, it should always be abstract. Always be abstract. But for other design patterns, like where you just apply inheritance, you have to understand the context before you can figure out if it's abstract or not. And usually the question carries enough information to tell you if it's abstract or not. And that's why we have to do a lot of examples. I mean, you've got loads and tons of past exam papers, and I want you guys to practice, try out these questions, bring these questions, let's discuss them together. Today, I pretty much did the solutions myself. As we move forward, that's not how we do these classes. You ask me a question, I ask you a question. So today is our first class. I just wanted us to get going, but otherwise from the next class going forward, I do ask a lot of questions. I want to know what you guys are thinking because I want to explain knowing what you don't know. Right now, I just went, okay, this is how it works. But I know if I start asking some questions right now, I'm going to figure out exactly what you don't know. And that's what we need to work through together, So what I'd recommend you do is go and try out some questions, try these diagrams out, send them to me, share on the group, whatever you're comfortable with. Because that's the only way you know that you've understood how to draw these diagrams. So you have to practice. Trust me, you have to practice because without practicing, it'll just make your exam difficult. Okay. So we are up in terms of our time and I don't see any other questions. Tomorrow you want to jump into reflection, right? And you guys don't have time, okay? That's why I've put lessons every single day. So you're gonna have to start practicing now. Like you should be going like panic mode today, like now, for the next 2 weeks, because you've got a lot of topics to cover. You've got a lot of concepts to understand, a lot of practicing to do. So I'm expecting you at least every single day to spare at least an hour or two to practice whatever topic we are looking at tomorrow. So if it's reflection, by the time we meet tomorrow at 7 p.m., at least spare some time to go through reflection videos. They're not very long. I think it's less than an hour for both of them. Then find some past exam paper questions and try them. Yes, I know you get stuck. That's the question I want to know. Why did you get stuck? What is it that it makes sense? Those are the questions we should be bringing to the. It doesn't matter how dumb you think your question is. Those are the actual questions, because that's what's going to happen in the exam. You see a question and then you get stuck. Then what? So the fact that you're looking at a question and you're not quite sure what it means, that means you've got a question. And I'm going to ask you questions also to try and figure out, what have you understood about reflection? What do you know about reflection? Where are the gaps? Why can't you do this question? And then my job is to fill in the gaps. Because when I look at the videos, you're going to understand something. You're going to not understand something. I want to know where you are. And then that way I can help you easily. So there's going to be a lot of discussions and talking happening moving forward. I'll be throwing questions around, expecting you guys to answer. And that way I know exactly where you guys are, where you need help, and we just move like that. But today, I did a lot of talking. So tomorrow we'll be looking at reflection, look at reflection videos, find some reflection questions. I'll put some questions together if you guys don't send any. But if I put questions together, I don't answer my own questions. So if I put questions, you're gonna have to answer them. And I promise I won't even answer them. If you bring questions, I'll help to answer them. So it's either or. So if there are no questions tomorrow, you attend the lesson, there'll be questions from me, and you'll be doing the answering. But if you practice and you find some questions that are interesting, I'll jump in and I'll help. That's the deal. That's how you're going to do it. So I don't see any other questions. That means you guys, I'm going to see you tomorrow.